Right here, this is a special character notation. The special notation here, it's a cumulative distribution function. The cumulative distribution function is negative like this. This is the mu, and this is the sigma. Then we like to calculate if there is an x. We're going to calculate the probability under from the negative infinity up to the position of x. The probability of the x. No, I like to. No, x is a. The lowercase s, the x is a random variable less than or equal to the lowercase, is defined as a 5 under. It's known as the CDF, cumulative distribution function. The CDF, cumulative distribution function of the standard normal distribution. I'm sorry, yes. And in which case, in standard normal distribution, what is the mean? What is the mean? 0. What is the standard deviation of the standard normal? 1. Very good. Yeah, very, very good. Okay, example, gonna skip that. No need to mention that. Okay, linear combo. So normal distribution has many useful properties, such as one of this is relative to the linear combinations of normally and independent distributed random variable. For each everyone, they can be called the IID. What does IID stand for? What does IID stand for, gentlemen? What? So IID stands for independent and identically distributed, known as IID. So if the x1 to xn are normally distributed and independently distributed with a random variable with mean, mu1 to mu n, and there are sigma 1 to sigma n. So then the distribution y still following the normal distribution. Whereas like this, since they are IID, so a1, a2, an are constant. For example, gentlemen, for example, there's a two random variable, they are IID. So x1 following the normal distribution with the mu1, sigma 1 squared. x2 following the normal distribution with mu2, x2 squared. Okay, then what is the distribution of the new random variable y equal to the sum of the x1 of x2? So we're going to check exploitation of the y equal to the exploitation of the x1 plus x2. That is equal to the x1 plus x2. Exploitation of the sum equal to the sum of the exploitation. So that is the mu1 plus mu2. No problem. And the variance of the y equal to the variance of the y equal to the x1 plus x2. That is equal to the variance of the x1 plus the variance of the x2 plus the two covariance of the x1 and x2. Gentlemen, because what is the covariance of the x1 and x2? Right or what is the variance of the covariance of the x1 and x2? Since that they are IID, so they are uncorrelated. So covariance is equal to 0. So they are independent. So this is sigma 1 squared plus sigma 2 squared. So there is another property, and a1 to an are constant, so the a1 needs to be squared out. Why? Why we need to put a square on the constant in front? Why? Why we need to square out of the constant in front? Why, gentlemen? Because Patricia, do you know the reason why? No? Okay, Miss Xiao. Why we need to put the constant square like the a1 square? Why? No? The lady from Vienna, do you know why? The reason why? How about you? Yang Ping? Yeah, sure. Why? Since this is second moment, the second moment equals the ax minus a mu squared, right? Since the a mu is the mean of the ax, so just put a square up out of the exploitation that is the x minus mu. Enter sequence switch. Okay, central limit theory, CLT, I mentioned in the last class.现在有没有比较好？你是确诊的？那很快啊，不到1个礼拜就好了。那等于是比较抗原，那第3次就2天就好，然后到了第10次的时候是早上得效就好。对。早上得效出病。那第2次的时候，喉咙会不会痛？会痛。早上得第10次，下午得第11次。你平常有运动吗？有啊，运动。有啊，有啊。给我闭嘴！你去罚站。太夸张了。真的，你自己去养母鸟啊！一直跟人家讲人家。你养个猫头也可以啊。对啊。去。莫名其妙，真的是。那是美娇奶，小黑弟。Okay, that's your limit theory. 老师，我证人。干嘛？你在羡慕别人嘛？对不对？ 自己的家园要自己去创造啊，对不对？站在树上看，
守护家园
也没有其他鸟要跟你在一起。
原来是没有海鸟和要那个我们臭鸟。
Central limit theory, x1 to xn are independent and variable with the mean mu1 and the variance sigma I squared. So if the y equal to the sum of the variable, they are IID, the distribution. So minus is mean divided by this square root of the sigma, the summation of sigma I squared approaching the normal standard normal distribution as n approaches infinity. When the sample, when we just increase the sample continuously and getting larger, then this variable will be approaching the standard normal distribution. Why we put that? The y is a sum, so the mean going to of the y going to be summation of the mean y, no problem. Since they are IID, so variance of the y equal to the variance of the x1 to xn, then we take the square root. This is a standardization process. Then subtract this mean, divide by standard deviation will approximate going to be approximately standard normal distribution with the zero mean and the univariance. So particle interpretation. So sum of the independent random variable is approximately normal distributed. It won't matter, regardless of the distribution of the each individual random variable in the sum. It won't matter. As long as so they are independent random variable. As long as they are independent, it won't matter the distribution of each individual. It could be the Pascal. It could be the binomial, it could be anything as long as the n is really large, like getting up to the 1 million, 2 million. Then this form want to approximate it by a standard normal distribution. Okay, log normal, I'm gonna skip that. So. Okay, then we go to the exponential. So exponentially typically it is frequently used to describe how long of the electronic component will survive, like the light bulb of the PCB or your CPU or the lifetime of the pad or any electronic component or your iWatch. How long it's going to survive. So it's only one parameter, lambda. It's a constant, and the mean of variance of the exponential equal to is a reciprocal of the lambda. This is a 1 over lambda. So sigma squared is the variances is also equal to the 1 over the lambda squared. So the mean and the variance of the exponential, the mean and standard deviation are equal each other. So like this is a typical illustration of the exponential distribution for selected of lambda. So lambda equal to 0.2. When you take the reciprocal, and 1 over lambda equal to 5. Take the reciprocal, maybe 5 hours. Every hour, there's a frequency is 0.2. Come on.
哎呦，认真听课的昆虫，
它属于昆虫吗？
什么？
是吗？
它有6只脚。
它不是只有6只脚，那是蟑螂吗？不要怕魏明俊，吃了。
哎，阿姨，来帮忙扫一下。Hello， 哎，帮忙扫。你起来一下啊！你站起来嘛！
站起来。
什么东西？蟑螂。你怎么看到？去头去尾就可以。直接就啪！
有找到吗？没有。
刚跑跑高，但是刚才从前面爬过去，大只的那一种。
蛋白质，蛋白质。谢谢。
So, if the lambda, the probability is low, the frequency is low, then the mean is low. That means it will survive longer. And if the lambda equal 0.0667 mu equal to 15, that means it survive a little bit longer. So you see that the shape like this, like a best top, the best top distribution occurs. Then this is CDF of the exponential distribution. So we just take the integration. So how long we're going to survive? Then this up to the 1.0, since we integrate to the infinity equal to the 1.0. So this is cumulative distribution function. So relationship between the Poisson distribution and exponential distribution. Exponential distribution is used to characterize the character how long that component going to be survive. On the contrary, the Poisson distribution, that means in the fixed time of the interval, how many failure will occur. They are reciprocal. They are on the contrary with each other. You know that since we take the reciprocal of the corresponding parameter. One is describe how long it survives. On the other hand, the Poisson distribution is used to describe how often it's going to fail. So lack of the memory. So lack of memory. Did I mention in my class? I think I did, right? Lack of memory. Yeah, did I? 现在我在我课堂上有没有讲说无记忆的特性？
有啊，你说这个有。
Yeah, something like this. Component. Once one is survive over 200, so it's going to survive another 200 hours. That's going to depend on how long it has been survived.
跟学校电脑一样。
需要电脑怎样？
不是关了他们就重置了吗
Yeah, this is all reset. So exponential distribution is the lack of memory property. This is theoretically true. Then to illustrate, suppose that exponential random variable x used to model the time to occurrence of the sign event, like a failure or breakdown. Consider the 2 point T1 and T2 greater than T1. The probability that event occur at a time is less than T1 plus T2, but the greater than T2 is just a probability of the event occurred at the time less than T1. So you won't forget it has been elapsed. So this is the same lack of the memory property we observed earlier in the geometric distribution. It won't matter the past has been occurred. Let me say that
看这个，乱吃，我觉得头超烂。
Okay, finally, you're going to have a probability plot. 3.4. Which is used to determine if the sample, the data, might reasonable be assumed to come from a specific distribution. We're going to check it. Probability plot. Typically use Kolmogorov, a Smirnov test, or the chi-square distribution test. So probability plot are available for various distributions. Don't worry about that. When I was a PhD student in the United States, we need to go to the bookstore to buy that probability paper. Then we calculate the probability and use a pencil to draw the point, to draw the line. If that straight line is held or not. If that straight line doesn't hold, and the hypothesis testing is going to be failed. So, probability plot available for various distributions is already in the computer. So, as long as you want to test the data to conform a specific distribution or not, if the repeat user Minitab, you just punch those numbers in the Excel format, and you just use the pull-down menu to select the distribution we'd like to test. So easy to construct with the computer software. However, it's a quite subjective interpretation that then, even so, there's another measure that can be used to test the hypothesis testing, if it's true or not. We use a p-value.
那个理论叫哪样立起来？这三种。哦。
So the null hypothesis is say that data conform to a specific distribution. Well, no, I will not say this data conform. And the alternative hypothesis, or H1 or H8, the data doesn't confirm the specific distribution. So p-value, if alpha is considered the level of significance, if alpha we set up with a 0.5, there's a 5% of the probability we commit the type 1 error. Then, if the p-value for that data we are testing against the hypothesis testing, then if the p-value is a 0.12, if the p-value 0.12 is obtained, and then do we support the null hypothesis or we do not support null hypothesis? Which one we should go for? Which one should go for? If the p equal to 0.12, lady, which one you should go for? If the p equal to the 0.12, alpha equal to 0.05. You're going to support the null hypothesis, or you're going to reject the null hypothesis. If the p value is a 0.12. Reject. Okay, that's your answer. Birdie, what is your answer? 你是怎样啊 ？Do you support? What? How about you? If the p equal to the 0.12, do you support the null hypothesis or not? Gentlemen, what is your decision?
诺海巴士，我忘记了。
虚无假设不一样。
是吧？
快点，你要回答，然后你就把小强给我找回来。你没有回答正确，你就给我找出来。
多少？
这等于是什么符号的？
多少？要看那个还是查表？
What is your decision? 两边
还是查表？
No, what is your final decision? You're going to
看那
support
个
or
里面
do
说
not
你
support?
用那个图，然后画这个线，然后看它是里面还是外面。
像这个图吗？
不是，它是那个标常那个那个哦。
Support. If the p is 0.101, so probability is so small. Under the null hypothesis, under the null hypothesis is true, the probability is so small, so which cannot be true. We're going to reject the null hypothesis. Under the null hypothesis is true, probability is 10%. Yeah, it's quite often. It's frequently, it's quite common, quite typically common in planets, right? Do you understand? No, I don't think you do. 来看一下，我用中文说一下。当我假设虚无假设是真的时候，这个资料是来自一个特定的分布。我算出来的 p-value 是0.12，是12%，代表什么意思？当我虚无假设是真的时候，这个资料是来自特定的分配，我求出来的几率是12%。哇，它发生，还常常发生，对不对？10%、20%，这个东西代表说，这几率还蛮大的。所以说，有没有证据来拒绝虚无假设？没有，因为它的几率还蛮大的。假如当我的虚无假设是真的时候，我算出来的几率竟然还不到1%，这不太可能发生嘛，对不对？太低了，对不对？那你要支持虚无假设吗 ？No， 发生的几率太低了。当你是真的时候，它发生的几率那么低，我怎么可能支持你 ？Reject the null hypothesis. Get it? Hope you get. Just write your explanation by yourself in your notebook. Patricia will understand. Under the null hypothesis true, if we get the p-value is like 0.12, 0.15, 0.20, yeah, quite reasonable to believe. Yeah, it's true since the probability is quite commonly high. If the null hypothesis is true, however, probability is low is less than 1%. That rarely happen to make us not to believe the null hypothesis is true. So we're going to reject the null hypothesis. Get it? Thank you. Yeah, this is so for this, the normal probability plot of the row octane number data. So you can see that 80 point. So plot that. So if the probability plot exhibit as much as a straight line, then we're going to support the null hypothesis. If there's a more deviate from the straight line, we're going to reject the null hypothesis. So we would like to see it is a straight line. More straight line is possible. So this is another thing. Okay, octane. There's another example of testing. This A, we test in the normal. B, log normal. C C variable and the D exponential. What do you think? Which one will be the best fit to the data? Xiaopeng, the student from Xiaopeng, what do you think? What do you think? Which one is the best fit to the data? Patricia, what do you think? Or the student from the computer science? What do you think? Which one will be the best fit? A, B, C, D. Which one is the best? 线加 B. B is what? Not normal, right? More straight line. It's possible. Thank you. Great.
那是越靠近这个越好。
So some useful approximation, which refers to the technical. Okay, then we'll do chapter. Before we do that with the homework. 第一章我们给大家讲一讲这个。然后
还没有。
没有，这没有。
我
所以我刚看了这个。高度呼吸啊。
有给吗？
给什么？
没有。讲义第四章。
没有。
没有啊。
聊合作。
有没有给？是你是老师读的。
在我。
32分，录音都进去了。
现在在工作业。
Yeah, somebody asking me, do I just solve the problem by manual or solve by computer? If you're going to solve it by manual, that would be okay. So, however, I still encourage you to do the homework by using computer. No, on the back, really on the back. Chapter 3. Uh, 3.25. 3.29. And 35. And 44. And 50. And 55. So going to do 1 week from today. Going to do next week.
10跟5题
6题啊，6题，
没错。看起来轻松的。这个前一题刚刚
是吧？差不多。
前一题。
你最后一天才会解啊？最后一天才会解。
最后一天6题啊。
最后一天6题。我们习惯一次 all in。
多么。
还有这个 USB， 这样，谁的那边可以插这个玩意儿？
可以吧？
可以的吗？
可以
手机可以
切出去。
直接插 USB 的。谁有带电脑？
老师，我可以。
真的吗？
你闯进来这里，
你有转接头哦。
真的。然后。
这么讲，
要讲。
哦。
是这样搞的。
我要注意了。
有料哎。
原来这些人哈。
生活骇客。
他要干嘛？他捅进来呀。
哎，把那个。
这边有资料。
1012拿出来，1012。
再把它上传。
上传到那。
好，我把它上传。
没有。
太多东西出来，太多改造品。
然后这爆炸啊！
把影片都播出来。
OK。
有什么影片呐？就是自然界的奇观而已啊。
这都是我认真读书的用具。
那个我从国中用到现在，非常老旧了。
好了，老师上传好了。OK， 谢谢，谢谢老师。这个是，对，
为什么想买一个？
这个好像900多块。因为他有附其他东西，他有附其他线那些的，他只是我只有带这个，然后这个收不起来。那万一挂来就只能再另找。
Okay, chapter 4. I think already sharing the light. Have you found? Have you seen that? Have you seen that? So we're gonna have a break. We're gonna break. We're going to continue. So we're gonna continue chapter 4. Lights up.
对哦，不会用的。汇入啊！
放学了。
他跟我抢球的呢。
放学了，放学了。你可以下载没？
受伤，然后他就直接趁机偷踢球进去，然后那男生就直接接球。
对啊，就那个啦。
直接接球，然后也受伤。没，
存到档案。
偷袭。那个妹给他一个皇冠。那个妹真的帅到。
我们爱。
在玩什么？电玩具啊？你们都玩什么？
还可以注意
你给我用后面这个。
我最近手不好，
那超难擦。
神魔萨的时候，他在玩这个。
哪有？
他忠实老玩家，
你明明有玩。
有啊，老师，我觉得
没有在用这种东西啊
有啦，
没有啦，你都玩这个，
太答对了，大概装一下
要来养
吧。
生的啊，现在学校啊。
啊，不好养啊，我只能养个，我就佐藤金肉店。
看这种错觉啊。
这是
哦，
女的，女的，
是啊，
女的，
因为本身养
她是女的。
不行啊，那个我家太小了。
可以啊，
我像社会大众吧。
人家没有粉丝感冒，那个100万订阅
最近刚，进货的，
可以玩。
他吃的会越来越肥哦。
是啊，那你是不是要买点心是喂它？
没有，我是要买饲料喂它。因为我是纯卖猪的，我卖猪会有钱，然后配种就会有新的小猪啊。
哦，God，
现在是3等的。